Hi everyone, welcome to another industry webinar series. But this would be our last webinar in this whole series of understanding an industrial perspective of building a prototype. So, once again, I welcome you all to this fourth webinar powered by Comedkares Innovation Hub on the topic of how to design electronic prototypes. So, with us, we have our speaker for today, Mr. Mukesh, who is the founder and director of Entra Mechatronics. So,
Yes.
a brief into our speaker for the day. So, Mukesh completing his mechatronics degree in the prestigious SRM University. He That's when he started his whole journey of creating automation and creating projects on automation of all the mundane tasks. For example, the first product that he came out was an automated hair cutting machine. So moving forward, he lives a dream of being in a world where human time and skills are more valued, and to live in a world where everything is automated. So that's when his quest of automating tasks started, and then he has founded his company called as Entra Mechatronics, where he's the founder and CEO. And this company has a wide range of products, where one of the really cool products that he's going to talk to us about today is this automated electric cooker. So that's our case study for today. And the product itself sounds so interesting, Mukesh, so that we are very much interested to know. So, what was the journey of this product of creating this whole automated cooker, and how was this journey like? And to know more about how what we can learn from your journey, and we can implement in our own journeys of building the product in this internship period. So yes, over to you, Mukesh.
Thank you for the sweet introduction, Hiteshi. Hi guys. Hope you all can hear me and see me clearly. I'm Mukesh Ravla. I run a kitchen technology startup called Entra Mechatronics, where we are trying to create series of appliances that can fully automate your kitchen. And also, I run parallelly, I run a consult firm where we help other startups or other funded companies and medium level companies to build their products, set up their factories, and also set up their supply chain from start to finish. So quickly going into the presentation, let me share my screen here. So today we'll be discussing about how to build a company primarily based on mechatronics products. Mechatronics is more or less robotic sensor technology, where you have a combination of mechanical elements where mechanisms or other hardware parts are involved in the product, and software and electronics would be assisting hardware in doing their tasks. So let us run through a quick exercise. So why we came into this space and why we are innovating here. Firstly, when you think of search engine, what are the 2, 3, 4 companies that comes to your mind? Then about e-commerce, what are the 1 or 2 companies that come to your mind? In the same way, cabs. But the problem with kitchen is it has been old for so many years that there are 30, 40, 50 companies that are operating in this space. So when you look at a startup or when you try to innovate something, you only have 2 options. You cannot go compete with the big guys. They're going to crush you right away. And it's very expensive to build your sales and marketing network. And 2 options that you are left out with: create a new industry or market for yourself, or get into a market where everything is monotonous and extremely old. So when you think of kitchen, cookers, electric cookers came in 1960s. Still the same. Couple of features are extra. In the same way, refrigeration came in 1970s. Still the same. You can operate it with your phone now, see what is going on inside your fridge, but fundamentally the core concept is still the same. In the same way, when you think about ovens or microwaves, came 200 years ago, still the same. So here we have seen an opportunity that we can do a lot in the kitchen technology space by introducing products, by not creating new technologies, but just mixing and matching existing technology to create cool products that can reduce a lot of our time. And one option why we wanted to get into this segment is that everyone needs, because people are getting health conscious on a day-to-day basis more and more. Everyone needs easy solutions, something like Swiggy, Zomato, where you click it on your phone and within the next 15, 20, 30 minutes, the food is on your wherever you are on your plate. So the one problem with this is, though it is convenient, it's not healthy. If it's healthy, it's too expensive. If it's healthy and cheap, you have to do it by yourselves. So here's the place where we wanted to come up with our series of kitchen products. So the first product we wanted to introduce is a cooker. Because of over 70% of the world consumes rice, grains, lentils, some kind of grain on a daily basis, at least 2 times a day. So we wanted to take off a major task. Though making rice is a just 35 minutes job, we wanted it completely autonomous, that you don't have to stand there, you don't have to wash the rice, you don't have to measure. Everything can be done by the machine. It's not just about rice, but you can make pulao, lemon rice, khichdi, any type of flavored rice or flavored dal or millets or quinoa. So we wanted to enter the kitchen industry with one product that could be sold to multiple countries at the same time with the same number of features. And the second one would be, as according to us, cooking or the job of cooking is not just about stirring ingredients or heating things. It starts all the way from you planning on going and buying your groceries, you making your shopping list, and then going out, buying it, coming back, traveling, then refrigerating. So we wanted to create a series of desks, or we call them prep pads, which could be placed, weight sensor prep pads, which could be placed under your containers, whether they are in the refrigerator or not. They can be connected to the Wi-Fi. And once you set a limit, suppose you have 5 kg container for atta or rice, and your minimum limit that you require for 2 days is 1 kg. So once it goes to that limit, the item will be reordered by itself. And it also syncs with your Google Calendar, so that when you are in holiday mode, it will push you to use up the things that are going to go stale in 2, 3, 4 days. And also not order when you are not at home. It also syncs with your location to make sure the food is ready whenever you wanted it. In that way, we wanted to create a series of appliances, which I'm sure many companies are now trying to do. In the next 15 to 20 years, you might get to see these products everywhere in every house. So our vision was to create a fully autonomous kitchen where human being has absolutely nothing to do but to eat. So about our first product, it's a fully automated cooker with that can measure the rice for you. Suppose you click 4 cups at 8 o'clock, though you are in office or college, it can do rice, grains, oats, or dal. It will measure for you, wash for you, soak if required, then cook fully automatically. It switches off by itself, it cleans itself. So before I tell you how we built our this product and how the journey involved in building the mechanisms, doing our prototypes, and also building our electronics, starting with the breadboard to dot board to a single layer PCB to a multi-layer PCB with 21 sensors. Let me give you a small disclaimer. If you are building a product to make it cool or out of your passion, you can follow whatever I'm telling in terms of building a product development, whether it comes to hardware or electronics. But if you are building it out of an intention to make money or build a startup out of it or create business out of it, do not go to the product first. In fact, even if you go till the prototype, go only till proof of concept stage, where you spend not more than 1 lakh or lakh and a half, because I've seen hundreds of companies who haven't figured out their market first and started building products, and 10, 15, 20 crores later, they realize they're in the wrong industry trying to serve the wrong market. So if you are wanting to build a product or do it as a product, cool, you can follow me, follow the rest of the presentation. But if you're going to do it as a business, you'll have to make sure where you sit in, which customer how is the product or the innovation going to make money for you, which industry is right for it, what's the size of the industry, how is the industry turning, what's the industry turning towards, what would be the market scenario 5, 10, 20 years later, how long can you survive in the industry, when can you sell your product. That thing has to be first, because investors also will go through this route. Their only concern is not your innovation or things looking cool. How much money are they investing and how much can they make back? First is understand the market, then understand your customer. What does the customer need? At what price, what features? After this only you can decide what are the features that a product involves and at what price point is it possible for you to innovate. Do not jump to innovating before understanding the market or before understanding where the money is going to come from. Because as a startup, it's easy to make products. You might feel it's very difficult, but trust me, it's 2, 3, 4 months journey. But as a company, when you're trying to build product, on an average, a hardware that kitchen technology, for example, all of you must be knowing a company called Rotimatic, a Singapore-based startup that makes rotis on the go. One roti in 30 seconds or so. So you must understand from an industry point of view, but that if you are trying to do something, the path to getting your certifications done, getting your marketing team, sales team, distribution channel done, it takes approximately 7 to 9 years, not months, 7 to 9 years, and a minimum of 150 to 200 crores to build a product in this competitive market. So if you are making prototypes with a vision of making it a big success in the future, first find where the money would come from now in the short term and also in the future. We cannot rely on investors for for a very long time, not more than 5, 6 years. Amazon or Flipkart must have done it for 10, 12 years, but it's not possible for everyone. So your investor journey should have a full stop within the first 3 or 4 years. After that, you'll have to make your own money, or at least find sources that the product would be sold. And also your sales channels, sales mediums, revenue streams, and also financial projections, accurate ones. After this is done, only then jump into a stage that is after prototyping. Do not do anything more than prototyping until these items of your business are fixed. If you're doing it just to make cool products, then you can follow. So I'll quickly run you through the journey of Entra Mechatronics, or how we made our first cooker. And this was back in 2016. So while I was of more or less similar to your age in second year, while I was in end of second year of my college, I have started off with a fully autonomous hair cutting product. I've built it for 2 years. I've got patents also on that. It did not succeed because I did not follow these. I wanted to make something cool, and I thought people would give me money because it's cool. That doesn't work that way. You need to make what people want at the right price and with the right features, and also market at the right time through the right mediums and discounts and marketing channels, distribution channels. So quickly run you through our hardware journey and electronics journey. I'll slowly take you through the hardware part first, then also explain you the electronics, because in our product, hardware is the king. Hardware is the core of the product that would be doing majority of the tasks, and electronics would be assisting the hardware, right? So this was back in 2016. We have started off making rice dispensing mechanism and also rice washing and dumping mechanism. We've started off very cheap, very frugal, everything that we could find on RoboKits or Robo.in or Adafruit, which all of you guys must be purchasing at the moment from. So those days we did not have Arduino Nano. We used to work on Arduino Uno, that too a duplicate made in China one. The original one was over 3,000 rupees. And we used to burn a lot on that also, because if you mismatch a little bit of wiring, the IC would be burnt off. You'll have to buy a new one. So in our initial stages, majority of our prototyping was done either on cardboard or plastic cut-off plastic bottles or 3D printed items like here. And we also did not have a microcontroller to control it. Initially, we only used SMPS. Before SMPS, we were using a normal 5-volt, 6-volt battery to test how the mechanism would work, then do the proof of concept. You need to be extremely frugal before you do the proof of concept. Once proof of concept is done, then you can start investing. So the first few months, we were only stuck with simple solenoid water pumps and DC motors and servo motors and a couple of cheap quality stepper motors and a few sensors. In fact, we didn't even have sensors for the first few months. So here we have done our proof of concept. Then within the first 6 months, 7 months, we have made a only rice cooker, not a grain cooker, but only a rice cooker where it can measure and also stir ingredients and also start cooking by itself. But everything is manual. This is to prove to our investors. Once the investors have been proven, we have done a thorough market research throughout Taiwan, Singapore, and Malaysia, and then realized pods, flavor pods that could put flavor into any type of grains, whether it's dal or quinoa or millets, to make it into a lemon rice, pulao or biryani, vegetable biryani. So that features were required. Then we started our third phase of prototyping. This was the first, this was second, and third phase of prototyping, machine started taking shape. Here we have started using microcontrollers, and we have broken down each and every mechanism. Suppose there's measuring and dispensing part. We had 7 to 8 mechanisms, tested all of them, and then approached faculties and people who are experts in this industry to make 3 more, tested all of them, use the best one. That way we have developed we have about 7 actuators and motors in the whole machine, and around 21 sensors which would sense the moisture, water level, water speed, and also the weight of the items being dispensed. So this was our third phase, where we have started building everything purely on mechanical basis. We haven't reached electronic stage yet. We were still playing around with Arduinos. So once you can take over your quiz questions, Hiteshi. I'll start the electronics then.
Okay. So students, I'll send the first quiz on the concepts covered so far. So quickly answer this quiz. We'll take a 2 minutes break and then join back and get into the electronics part of it.
So coming to electronics, the earliest days, the problems I have faced personally, and many of you must have experienced while presenting it to investors or your faculties, is that the machine or the whole concept will work amazingly, beautifully when you are standing there. In your absence, it may not perform the best, and you are the only one who knows how to fix it. So for these reasons, it is extremely important to document your codes or your wiring every time you develop. Even a small change you make, it has to be documented, that any universal person with basic level engineering would be in a position to fix it or make it work whenever it's not working. That being said, it's applicable only for prototypes, because when it comes to the final product, the product might be 2,000, 3,000 kilometers away from you. The customer must have paid 90,000, 1 lakh rupees with a 5-year warranty. If something goes wrong, it's going to be more expensive than what the profit you made on the product itself. For those reasons, it's extremely important to make sure that what you are making is reliable first, and also robust. And that's the main reason why companies do not work with Arduino for more than a week, 2 weeks, 3 weeks. They go for PIC or ARM based controllers. I'll also tell you when to do that stage. Yeah. So this is, we have shifted from breadboard to a dot board within the first week or so. We used, because we had so many sensors, around 21 sensors and around 8 actuators, and overall operations were approximately 65, 70 operations, and number of parts involved in the machine were only around 850, 900 items. So for those reasons, it was not feasible for us to work with Arduino for a very long time. But I'll tell you how the transition works and how you must think about it while going. So firstly, breadboard is used only to test 1 actuator or 2 actuators. When you're doing when you're doing activities where more than 5 actuators or 5 items are involved, then chances of going wrong would be substantially high. If you calculate the probability, it's going to go by square root. It's not going to add up, or it's not going to multiply. It's going to square. 10 items you are using on breadboard, it's going to be 10 times more difficult than 1 item being used. 10x more difficult than 1 item being used. So the leftmost one was our initial proof of concept and prototypes, where we've used dot board. Nothing against breadboard, but just that dot board is more robust, because the wiring and soldering would be in our control, and also all the breadboards are not built according to the same standards. Because our voltage, we also use AC current. Breadboard can't take AC current. It's gonna burn off very easily. And we wanted to use something that could be used as a prototype for at least 2 to 3 months. We've started off with dot board. And the point when you go to transition to a complete PCB with your own microcontroller is, complete PCB with your own microcontroller is when it's getting extremely difficult for you to mix and match or track the wiring or document the wiring. Though the wiring is extremely documented, all the dots are not numbered on any kind of PCB or breadboard. When it's extremely to ditch a Arduino or a Raspberry should be first cost. The making a PCB of your own must turn out to be cheaper when it comes to 3, 4, 5 months. Number two, the number of pins. We know that Arduino, these developer boards come with set number of pins. If you are going, 1 second, internet is unstable. Yeah. If you are going with a concept where the number of pins are not sufficient for you, or not able to take the power of your actuators or sensors, or your sensors are too complicated for a simple Arduino to handle, only then you'll have to move to PIC or a ARM based controller. Other than that, majority of the startups make this fancy mistake of shifting to a ARM or PIC board. In fact, trust me, I've seen so many companies, even the ones who are operating at 200, 250 crores, first 6 months to 10 months, they stick with Raspberry or a Arduino Mega. They do not go to their own board, even though they have so much of money. Because when it comes to building something and doing trial and error, these are the boards which are very flexible. Suppose you look at this board. This has touchscreen sensors. It also has air sensor, it has humidity sensor, it has dust sensor, and it also has a display unit here, and multiple other features. It has LEDs and multiple other features. So once we make something like this, when we want modifications in this, it's not possible to solder a multi-layered PCB. It has to be done electronically only. And let me also tell you when to transition from a PCB to a multi-layered one. When you are giving 5, 7, 10 years warranty on this, it's not just about crushing the size of the PCB. Suppose when you are going for a multi-layered one, you might be requiring 6 to 7 square feet of PCBs. If your machine is accommodating it, go with it. Though doing a multi-layer one is cheaper, go with a single layer one when the machine is accommodating it, primarily because it's easier and cheaper for you to modify it. It's as flexible as an Arduino, not as much as Arduino, but it would be extremely flexible for to make changes or understand where the improvements can be done when it's a single layer board. Multi-layer board is used by us only because some of our components or some of our the connection between some of our wirings are going to be extremely sensitive to dust, humidity, cold weather, hot weather, such things. And when we are giving 5-7 years warranty, we need to make sure that those specific wirings which are consisting 240, 300 volts of current being passed through, they are sandwiched between two different types of boards, where the wirings are more or less are regular sensors, 5 volts, 7 volts, 12 volts. So that's one of the reason why we go for the multi-layered boards. And when you are firm on the product, after 10, 20, 30 iterations, and also at least a year and a half of customer testimonials and customers using them, only then you transition into a multi-layered board. I understand these days drawing a Gerber file and uploading it to a vendor and you get your multi-layered board within 3,000, 4,000 rupees. It might sound fancy to you, but stick to the basics until your mechanism or the core functionality of the product is fixed. Do not jump to fancy items without fixing your functionality or the features. And do not jump to functionality or features without knowing where the money is going to come from. Your investors or your consumers or the distributors and the retail agents. So this was our journey. This was if you look here, this was 3 years after we have started building our machine. If you look closely, we are still using an Arduino. That means that when your product is in a advanced, pre-prototype stage or pre-sale stage, you need to be extremely flexible with the features, which a custom board or a custom PCB cannot do. Even while you're ordering PCB, take 20, 30, 40 pins extra. You don't know what other sensors can come. And some sensors require more than 6 pins, which I know. So always be extremely flexible and do not limit yourself, especially when it comes to electronics. Number of pins, it's not very expensive to build electronics products. So number of pins, take 30 to 40% extra, more than what you need. And number of transistors, resistors, everything, keep it extra, more than what you need. You don't have to use the complete board. Use just 60% of it. Rest 40 has to be extra, just in case something has to be expanded. And also leave free free spaces where you could use jumper wires to manually adjust your PCBs. A PCB cannot be considered final until it's being sold. So even 3 years after we've started the product, built the product, sold few units, even after that, we've always believed in Arduino Mega and also Raspberry in order to connect to the internet, because all of our products would be operated by the phone. We had our own firmware department and cloud department. However, all our prototypes, in fact, one step before the sales is done, till then we test things on Arduino only. And with this, you will get a flexibility of, suppose you are giving a 5-year warranty. How do you test it here? Product might be used in Kashmir or Rajasthan. We keep the product in sun for 8, 10, 12 hours in hot sun, then bring the product back to our lab, put all our sensors, all kinds of sensors that could track the electronics, then operate the machine. Everywhere you might, when we were operating it, when while doing the dispensing mechanism or washing mechanism or water motor mechanism, we have realized a gap of 0.3 to 0.45 seconds in few operations. It means that if that product which is kept in the sun is going to Rajasthan or a place where the person is going, you don't know where the customer will place the product. If the customer is placing it right next to the window and sun is hitting it directly, after 1 or 2 years, it's not going to work the way it is, because for 12 hours the lag we are getting was 0.3 seconds. If someone uses it 2 times a day or 3 times a day for the next 6 months, 1 year, 2 years, the product is going to fail in 2 years easily. In that case, you'll have to find alternatives. Your product must be efficient. The efficiency level of your product will be only 30 to 40% of the capability of your board. Again, efficiency. At the moment, all of us with Arduino and Raspberry, with majority of things that we buy on RoboKits or Robu, they operate at an efficiency of 65% to 80%. But when you are selling it to the consumer, your efficiency, the amount of energy or the features that the product is going to use should not cross 40%. 60% has to be the safety, because 1, 2, 3 years down the line, that 40% will go to 80 or 90%. Same with our phones. Even the best phone is going to lag after a few years. The same with the electronics. In the same way, we've also tested it by putting it in huge refrigerators, freezers for 10 hours, 12 hours. Then open the machine, suddenly shock it, switch it on, turn on the cycle, start cooking 4, 5, 6, 7 times at a time. Then check the timing, then check the temperature of the wire, jumper wires, and also temperature of the IC. Is it at optimum? Is it going to burn? In fact, while developing a product, at least 8, 10, 12 products will be burnt by ourselves in the process of testing. That's the reason majority of the car companies would do this crash test, not to get certifications, but to ensure that in future, if 20, 30, 40 products are going to come back as a faulty products, they'll lose the profit of 400, 500 products in order to fix that 20, 30. For these reasons, it's extremely important for you guys to be very accurate and very conservative when it comes to electronics. Use only 30, 40% of the capacity. Even with the SMPS, you'll have to build your own SMPS. Here we are using a ready-made one. We used to get it from Singapore. Yeah, ready-made ones are good for prototypes, but when it comes to products, everything has to be in-house. That's the reason a majority of these companies, even who has just 1 product, 2 products, their development team, the product development team would consist of at least 200, 250 people, at least 60, 70 people at a salary bracket of more than 3 lakhs, 4 lakhs a month. So moving forward, this was the final product, the transition from what we had initially to from 3D printed one to the final product, which we've sold to multiple customers. This is a fully automatic one. If you see closely, you understand that the shape of the vessel and the mechanisms of dispensing would have changed. It's completely touchscreen. It could be operated from your phone. And you can also see the status of the machine whenever you want. It cleans by itself. The lid would be opened by itself. So reality check, finally, again, I'm coming back to the same thing. I understand that this is a electronics and hardware session, but yeah, If your intentions with your product is to make money or make a product, make a business out of it, always ensure you are in touch with the customers and also your distributors, because they know the customer intent and customer persona more than anyone else. We can be open for questions.
Yes, thank you, Mukesh, for that exciting journey of your first product. So before we move into the Q&A section, there is a small quiz for the students, and also a little bit time for you to think about your questions and start posting here in the comment. So we'll take a 2 minutes break and then we'll resume at 12:40 for the Q&A section. The second quiz has been posted in the chat and also in your WhatsApp groups. Please take up this quiz and use this time to also think about the questions that you want to ask our speaker and get it answered in the next 20 minutes.
Yes, I've started with the questions. I'll show you a quick video of our product. So this was the 6th or 7th prototype that we have made. This is not the final product yet. I'll show you a quick video. This is how the product looked. So this is our it had almost all the features. It did not have the flavor pods or the technique of measuring vegetables or other add-ons that could be added into the container. And also in the final product, we had 3 different types of grains that could be stored. In this one, it's just one. The final one was around 14th prototype. This is the 6th or 7th one. It had touchscreen and it could be operated by a mobile phone. That was the only feature in this. So here Thomas is opening the container. He's filling rice in that, and he's putting in how many cups he wanted to cook. Also here we have a timer. Yeah, here the yellow button, if it is clear, we have a timer that could be used by setting up this to ensure when the machine should start and when it should stop. As you could have done it on your mobile phone also, and you can also modify the amount of water that could be gone in terms of ratio, and also the soaking feature. And the indications we have, yeah, and the bottom lights which you see, those are the indications, representations of our sensors. How much water is there in the container, or is it connected directly to a tap? How much grains are left out, or is it connected directly to another bucket that could supply grains to this? And is the cooker, the bottom one cooker, is in position? Is the lid closed, open, or is the lid closed? When did it start cooking? And finally, is it ready or not? These were all the indicators we had, and these were the input features that we had. Power on, power off, opening the lid, closing the lid, measuring, starting the process, stopping, halting it in middle, or modifying the amount of grain to water ratio, and also putting a timer. So as soon as you start, one of the mechanism lifts the lid up and opens. Then all our process of draining and stuff would start. And finally, yeah, after washing and soaking for half an hour or so, it does 2 rounds of this. Closes by itself, and the indication has changed that it's cooking. So this was the initial product. Yeah, hope we can go down to the questions now.
Yeah.
Stop sharing my screen. Yeah.
It's quite an amazing and a cool product that you've built, and thank you so much for sharing this whole journey. And kudos to the entire team.
Thank you. We've built many other products which I can't disclose because we already sold it to someone else. It's someone else's product now. So yeah, built a few more me along with Thomas. So let's look at the question. Since it's an electric cooker, what happens to the process if the power supply goes out? Is it inbuilt battery? Yes, rule number 1, when you are selling electronics, heavy electronics, never give battery. Batteries, when you have SMPS, wanted to tell this, but you can add a battery, of course, but you'll have a BMS, which is extremely notorious and also has a tendency of breaking down. In fact, you must have seen recently that around 200, 250 Ola bikes have burnt right when they were in the truck. without, when they were covered in the truck. It was not even hot over there. So when you are dealing with batteries, it becomes extremely complicated because your BMS has flexibility. Again, what the flexibility item I told you, right? About 30 to 40% of a product must be I mean, the range of flexibility must be at least 60%. The operation must be only 30 to 40%. And when you are using an SMPS with a steady power source, you have a constant or predictable input. Even if it's not constant, the SMPS is going to step it up or step it down. The problem with batteries is, even if you buy a brand new battery from the same store, from the same packet, both the batteries would not have same kinds of output. It would go slightly up or slightly down by 2 to 3%. 2 to 3% when you are giving a warranty of 5 years makes a lot of difference. The battery that it's going to, a rechargeable battery, of course, we'll have to give something like that in this. When the battery is given, the first month, the kind of operation, the kind of efficiency would be different from what it would perform 6 months later. We understand that, but the electronics does not understand that. It's going to end up burning something, or if you constantly supply lesser than required power, it's going to damage the IC. If you do it more than required power, it's going to burn it right away. For those reasons, I would recommend you to do not touch batteries or do not go to battery management sites until you have a post graduation. With undergraduate skills, it is extremely difficult to build a reliable battery management system. That being said, when the power goes off, it's connected to the Wi-Fi. We have a small our ICs have a backup of 5 seconds with a smaller battery, which has extremely predictable, and even if it fluctuates, doesn't make much difference to the effect to the motherboard. So we save the process. Our process would be saved from wherever it goes. And if the power goes for more than 5, 6, 7 hours and the rice is in the soaking stage or cooking stage, we send a notification to the customer that it's better they dump it. If it goes for 3 minutes or 4 minutes, it's going to start from wherever it has gone. So we have a 5 minutes memory loop where it remembers what has happened before 5 minutes of 5 seconds, sorry. So the second one is, how do you measure the, we had more than 14 mechanisms for this. You can do it by standard jar, like you do it in your cups. Our final product had cups. We also had weight sensors. We also had flow meters that are used in plastic injection molding factories, where chips are measured depending upon the flow. So rice is also of similar size, grain size. So that flow meter, we had 14 different mechanisms. That's again not trial and error. It based on experience. If you're hiring really good guys, they would get it in 4 errors. If you're hiring a newbie, he would get it in 10 errors. That's the only difference.
Yes, Mukesh, before you go to the next question, just to the students here attending, I could see somebody raising your hand. So if you have a question, you can post it in the chat box. I think Saujanya had raised her hand. I'm assuming you had a question. So Saujanya, you can please type it here in the chat and into any other students who are attending from their mobile devices. So Mukesh, also before you go to this next section, next question in the chat box, I have 2 more questions.
Can we get, yes. Can we get high precision products using Raspberry and Arduino and Raspberry Pi? Of course, yes. When you are going for medical devices or extremely high German products, like for example, when you see your batteries, if you go to a battery factory, every battery has a serial number behind it. And the gun that is spitting the ink on the battery has to make sure it's doing it at the same spot when 4,000 batteries are moving per minute. 1 minute, 4,000 batteries. It has to shoot the ink at that accuracy. If you're expecting something like that, Arduino and Raspberry is not the way to go. But for everything else, it's flexible enough. You don't have to worry. For majority of the projects that you and me do on a daily basis, Arduino is good enough. So the next question.
So we have a question here. How do you prioritize your components? Was it all trial and error? Also, what would you suggest newbies in the field of electronics? How do they go about building their prototypes? I mean, the background is because all the students here are first year graduating students from different backgrounds. Not all having electronics as their background. So they're asking, how do you prioritize components? And also adding to this, I would also like in terms of deciding your features of the product that you're building, what kind of features should I keep prioritize for my prototype stage, and what should I keep building upon as I move ahead in my prototyping stage?
Understood. To answer the first question, prioritize is not. It's not about prioritizing. It's again not even trial and error. When you understand, when you are extremely accurate of what you need out of that specific electronic component, and you, as I told, the amount of load it's going to put on the motherboard or the Arduino or Raspberry, whatever you're using, you have to stick to a range of 40 to 60%, both in terms of speed and also in terms of electric flow, ampere flow, voltage and ampere flow that the specific component can handle. That being said, that would be the first step, which can give you a series of ICs or types of ICs that could be used. And second step would be going for the quality. If you are building something for the next 15, 20, 30 days, go with the cheap Chinese products where you get majority of the components for 15, 20 rupees. And German and US ones are within the price range of 650 to 1200 rupees per IC or per component. So there's no one answer. It's never trial and error. Trust me. You have to have a very accurate, very segmented path from before. And it's trial and error when you have two options of same kinds. And if the first one works, you don't even have to try the second option or burn the second item. Unless you're wanting to do it for 3 months or 6 months, then you can try going 2 times, 3 times, 4 times your limit and see which one is lasting longer and then do it. So the second one is features. Features again, biggest mistake people make is to do what they feel cool. Features, purely customers. Do not use your brain. Use the customer's brain and the people who are dealing with customers. These sales agents, marketing agents, and distributors who have been selling similar products to the customers for the past 20, 30, 40 years. They know the exact pain points of the customers. Do not use your brain to build features or understand which features to put. Now I could put it's not very expensive for me to put gesture control or voice command to it, but it's not something everyone is convenient with. I might feel it cool, but it's not what a customer would pay extra for. It's going to cost me extra if I do it. So stick with people who are selling it to the customers. And if it's your product, if it's just a project based ones, it's okay to take feedback from what's currently there in the market and mix and match in order to build one product that could represent 20, 30 items, which could have features of 20, 30 competitors. Or at least if you can build a new feature that might be supporting you in terms of cloud computing or touchscreen or something that you feel cool, you can go with it. But on an overall basis, when you're building a company, never use your team's brain or your brain to decide what the customer wants.
So there was also a last part of this question about what would you suggest newbies in the field of electronics? How do they go about building their prototypes?
It again comes down to problem statement. Finally, do not build. Of course, nobody builds products just for the sake of getting grades or building things. What problem are you trying to solve? Are you trying to make a better remote or a better self-thinking machine? And based on the result only, you'll have to understand the features. It's totally different from problem to problem. So your problem statement would have half of the features already described in it. Be extremely clear of what exactly you are wanting to solve, for whom, at what price point, within what time, and what should be the size of it, things like that.
Okay. The next question is, with electronics, we never know what goes wrong. What are your suggestions on testing of electronic components? Could you also shed some light on power management on boards? And also last question, what are your thumb rules when you place your components on a board, because all prototypes looked so neat?
Yeah, see, when you are playing with less than 5 or 7 actuators or sensors, it's okay to stick with breadboard. But the problem with breadboard is not very reliable because you'll be playing with jumpers. In fact, here's a short story. After we have shifted to multi-layer PCBs, we realized we had a few breadboards in stock. So my electronics guy came and told me we have nothing to So let's see what's the capacity of these guys. The breadboards. We had generator at that time, which could produce more than 6,000 volts. So we put all these breadboards with heavy fat jump. We made bigger holes, put fat jumpers in them, and came out of the glass room, and we started our generators to see what's the capacity and how much are these capable of. The 300, 350 rupees ones. This two breadboards with same kind of testing, taken from the same shop, opened from the same seal. One burnt off, blasted like a bomb in 9 minutes. The second one just popped off with a small sound after 3 hours. So it's, of course, yes, electronics are not predictable, and the components that you buy, even if you take it out from the same shop, buy it from the same shop, take it out from the same box, both might have two different capacities. Because when it comes to developer or project-based electronics, that's the accuracy which the manufacturer makes, because you don't need more than that. And the problem with breadboard personally is when you're going for more complicated things, if something goes wrong, you will need at least 1 to 2 hours to understand what has gone wrong, and 10 seconds to fix whatever has gone wrong. So the problem of figuring out what has gone wrong is extremely difficult when you are playing around with breadboards or jumper wires. So if you are building something complicated, I would recommend learn soldering. Very simple. Go to don't go to invest into PCBs. Go for a dot board, and then do your then do your wiring. And wherever possible, make sure you have put sensors to indicate the voltage and ampere to you. So you will at least know. Suppose there's a long circuit and something has gone wrong. You don't have to keep testing each and every item. If you have put your voltage or ampere sensors wherever you could, you will understand which segment has gone wrong and then go fix that part. Because fixing electronics is very simple and easy, but finding out what has gone wrong is the most difficult part.
Yes, true.
So next one is, why did it take 9 long years to make prototypes, sir? Wanting to make electric? No, the prototype, we've made it in 6 months. And the final product, it took around 3.5 years. 9 years, I was talking about Rotimatic. 9 years, yeah. I'll answer this. Yeah, this was initially we also had this kind of thought. Why are these guys? These guys are PhDs from top universities from the world. Why are these guys spending 200 crores and 10 years? Are they stupid? I can make it in 1 year. Doesn't work that way actually. Yeah. When you are going to a consumer level, each and every when the certification agencies would test your product and at each and every specific component. Suppose you have a motherboard that's communicating with 21 sensors, 22 sensors, and also communicating parallelly with 7 to 8 actuators. What could go wrong if the temperature is too high? What could go wrong if the temperature is too low? And majority of our prototypes do not work at those levels, because we'll be giving warranty and safety. Electric shock shouldn't be there. Every machine should have earthing feature inbuilt. When you're going to that level, initially while you're making prototypes with Arduino and Raspberry, you can keep shifting or changing things every 2 weeks or 3 weeks. But when you have gone to a custom board already, everything is in place for testing, and testing doesn't work out, a full round of revamp would take at least 2 to 3 months. It's not just about electronics, but the communication between the electronics and sensor. What the sensor tells has to come back to motherboard. This motherboard has to indicate that to the actuators. In fact, the cap lifting and opening mechanism you have seen, that has a power of more than 176 kgs. Suppose somebody put their finger in somewhere between the actuator and this, finger will be cut off very easily. 175 kgs, that actuator. It might look 400, it might be lifting just a 400 gram, the lid, but it's a cantilever beam. When you go for a cantilever beam, the amount of power required multiplies per centimeter. And again, after that, you'll have to make sure you're only using 40 to 45% of the motor for safety reasons. And after that also, you'll have to make sure you're supplying the motor with adequate power with a fluctuation of 0.03% up or down, whatever is the power surge, or even if the electricity goes. So these are many things that you need to take care of when you're going at a commercial level and when you're launching it on a commercial level. For instance, if you consider Ather Energy, majority of you might be knowing the scooters, that has cost us 700 crores The prototype was made in 55,000. From prototype to the final product, 700 crores, 350 people. That's the amount of work it takes actually, where you'll understand it when you are trying to build it for a consumer. When you're building it to impress your teachers or for a project coordinator, you can play around with Arduino and Raspberry. But when you're going at that stage, you're buying a Arduino or a 10,000 rupee item, doesn't matter, because the value of the final product is that much.
Yes. So yes, okay. So we have reached our time limit. So we would end this for here. And I have a few more questions in my chat. So they have DM'd it to me personally. Maybe post this session, I'll just send it to you and we can get that answer. Like I have 4 more
Sure,
questions.
sure.
So, well, Mukesh, it's quite an interesting product that we heard from you, and the thought process that you had while solving this has been quite interesting. And also, the questions that came up were also very interesting. And I hope the answers that you have given has really shed some light in their own process of building their own prototypes for in this internship period. So, thank you so much for that, Mukesh. Thank you.
Thank you so much for having me here. I've thoroughly enjoyed talking to you guys.
Yes. So with that, I also thank all the audience for being such a great sport and asking such curious questions. And with that, not just for today, we have with all the 4 sessions that we have conducted so far, I believe it has shed enough light in terms of understanding the design, how to build prototypes from an electronic for an electronic product, for a mechanical product, for a digital based product. So hope all these sessions have been really useful to you. And thank you so much for being such a patient audience. With that, thank you everyone. Have a great noon and have a great day. And all the best to all the projects that you have been building. And hope to see you all on 27th with the great prototypes that you will be building. So with that,
Sure.
yeah. Thank you everyone. Thank you, Mukesh. Yes. Bye-bye.